Hello guys, welcome back, and today I'm discuss with you about the different applications of the disjoint set. So basically there are two different applications are there. One is equivalence relation is called the connected components, and another is minimal spanning tree. So equivalence relation or the connected components algorithm we are applying to find out the relationship among the given set or the graph and to different graphs, and the minimal spanning tree basically to find out the minimum spanning tree applying the design set in the Kruskal's algorithm, because the Kruskal's algorithm follow the ages, okay, minimum ages. So that's why we are applying the design set in the Kruskal's algorithm. The applications of connected component is basically we're applying the connected component algorithm in the social networking. Why? Because the social networking research studies how the relationship between the various people can influence their behaviors. Okay, that's why we are applying the connected component algorithm in the social networking to find out the behavior of different peoples or okay. So if we consider that ace is a set and there is contain the n number of people, okay, and if we consider the t is a subset of ace, that means if we consider the social network is a set, and the social network there are different social networking sites are there like Facebook, Instagram, Twitter, and there are in number of peoples have an account in Facebook, Instagram, and Twitter also. So if we are finding out the relationship among them, that means if we consider the Facebook, and if we are finding out the if in is there any relation of the people X with the people Y. That means X is a friend of Y, or X is related to Y, like friend of friend or friend of friend of friend. Like this, we are calling is the mutual friend. We are finding out. So using the connected component algorithm, we are finding out the relationship. The is there any relation among those people have an account in the same social networking site like Facebook, in the only Instagram or Twitter, but we did not find out any relation among those people who have account the two different social networking site, the Instagram and Facebook. We did not connect them because there is no relation between the Instagram and the Facebook, but we can find out the relationship among those people who have account on the Facebook, who have account on the Instagram, who have account the Twitter. So within this Facebook, within the network of Instagram, within the same network of Twitter, we can find out the relationship. Okay, then we are applying the connected component algorithm. So basically, the primary operations of the connected component algorithms, we know the concept, the make set, the find set, and the union set. Actually the make set function, using the make set function we are creating a new set containing only one element. Like if we consider the if we apply the make set function and x use as a parameter, then we create a set, with the name of the set is si, and then it contain only single element is x. Next, the find set. Actually, the find set and use as x as a parameter, and it will return the ID of the set. And that means if x is element of si, then it will return its set ID, that is si. Okay, if x is the element of set sj, then it will return its ID, that is sj. And union operation. Actually, you are applying the union operation to merge the two different set. So then we are applying the union operation. So actually the performance parameter. So what will be the performance parameter for the connected component? There are two mainly performance parameters. Mainly parameters are used. That is, one is m, another is n. So m denotes that the number of call to find set and the union operation. So actually m denotes the how many times the find set and the union set function calls, and n is the number of elements, the number of calls to make set. That means actually define how many times the make set is called and how many number of elements are there. Okay, so there are two different parameters we are using. And the applications like the dynamic connectivity over initial empty graph, this is also called the connected component. And there are add node functions, add edge functions. There are two parameter uv and is connected. So basically the add node functions is none other than the make set operations, and add age function is also called the union operation, and the is connected the same as the find set. So you can see the three different functions, the operations of the design set, or you can say the implementation. So already we have learned the how the work, how does work the make set, find set, and union. You know the make set function actually used for the creating the single element. So if there is only single element, that means the parent is also the uh, same element. So x of parent equal to x. Okay, this is called the single element. And function find function, x used as a parameter, and if there is only single element, that means the x of parent equal to x, then it will return the those element. And if there is more than one element, then it will return the its parent, corresponding parents. Like if two one is the parent of two, then if I call find two, then it will return one, because one is the parent of two. But if there is only one element, that is only one element, and the name of the element is 2, and if I call find 2, then it will return 2 itself, because the only single element 2 itself are root. Okay, so then it will return 2. And the function union x and y. So we know the x and y is the two different set, and for first we call the find x and find one, and then it will those functions, using those functions we are finding out the root of x and y, and then we just merge together. In this case we consider the x as a root element, and that means x root dot parent equal to y root. That means uh, y used as a children of x. Okay, that means y and x both are root to different set, but when we merge or applying the union operation, then we consider x as a root and y as a child of x. Okay. Next, the connected component. Actually, basically there are two different functions are there. One is connected component of g, and another is same component of uv. So that means using the connected component, you can see here the given graph capital G. We first we process the G to maintain a set of connected component. Like if you have a if you have given a graph, okay, capital G, and applying the connected component function to this given graph, and then find out the all the connected component belongs or stay in the given graph. Okay, graph set. Okay, and then after that we apply the same component. Using the same component, we are finding out the two different age belong to the same graph or in the different graph. Okay, so first we apply the connected component in the g use as a parameter. Okay, and then we find out all the components of the given graph, and then we apply the same component and then find out the two different vertices are belong to the same component. That means the same graph or in the two different graph. Okay, if it belong to the same graph, then it will return the true. If it does not belong to the same graph, the two different vertices belong to the same graph, then it will return false. So let's see the functions or the pseudocode. The first, this is the connected component function, and actually it use the g is a graph. Okay, and use as a parameter. Next, for each vertex v in v of g, that means the v is an element of vertex set we have in g of b. Okay, that means if you consider g is a graph, and the g graph is containing, the vertex set and the edge set. So for each vertex v is in g, if the each vertex v small v is in the vertex set, then we apply the make set operation to create the vertex set, or to or the actually these vertex we call the make set function, and that means that we create a set for each the vertices. Okay, so that means if the vertex small v belong to the vertex set of the given graph, then we apply the make set operation, and using the make set function, we create a set for each of the vertices. Next, we use the for each edge uv is belongs to the e of g. That means the age, then we find out or we can just take one by one age, and the age, if the age belongs to the vertex set, or sorry, the age set of g, then we apply or we the find set operation. That is how we apply the if condition. Then we check that is the find set of u is not equal to the find set of v. That means first we take one edge, and if the edge is belong to the edge set, then we check the two vertices of the edge, that is u and v, are in the same set or not. If they belong to the different set, the find set operation belong to the different set, then we apply the union operation. Okay, that is u and v. Then we join this u and v. Okay, and after completion of the all the connected component functions, okay, after completion all the edges, or you can say all the elements of the set, then we apply the same set component, and then check the if the two different, that u and v are set belongs to the apply the find set function, and if they belongs to the same set, then it will return true. If not, then it will return false. So let's take one example. So you can see this is the graph is given, that is this is a connected one connected graph, this is another connected one, and this is another graph, only single vertex. Okay, so being with this input graph, so this is the inputted graph. So you consider the, this is the graph g, and g is the consists of the vertex set and edge set. The v is the vertex set a b c d e f g and h, and e is the edge set, that is a b c d e f b c b d and f g. Okay, next step one, first we apply the mix set function for each vertex v. You can see the algorithm for connected component. First we apply the make set function for each vertex v is belongs to the vertex set. Then we choose one by one edge and check from the edge set, and then apply the then we check the find set among this u and v, and if these not belong to the same set, then we apply the union operation. So first we uh, applying the make set function, that is make set v. V is the vertex. As first we take one by one vertex. Okay, and for each vertex set a small v. So we create, first we create the applying the make set function, and then we just create the individual vertex. Okay, that is a single element, all are the single element a b c d e f g and h. Okay, create a single element. After that we apply the visit edge one by one. We visit the edge and apply the union operation. So first we choose uv, and then this is the you can see the this is the given, or the after applying the mix it, we are just get this vertex, and then we apply the first in step 2, that is visit ab. So first we choose the ab from the this set. First we choose the ab, and we are applying just we are applying this function, that is the first check the find set u is not equal to find set v, that means a is not equal to b. Then we apply the union operation, then we join the a and b. Okay, so you can see. So first we take the AB, the age set AB, age AB, and then we check is A and B belongs to the same set. It's not, because A and B does not belong to the same set, because A belong to the A and B belong to the two different set. Then we apply the union operation and then merge A and B. Okay. After that we check, we take next age, that is CD, and you can see C and D belong to the two different set. Then that the find set is true. That means the find of C is not equal to find of D. Then we apply the union operation and then merge C and D. You can see merge C and D. Next we take another age like EF, and you can see E and F is does not belong to the same set. E and F belong to the two different set. Then we apply the union operation and merge E and F. Next we choose the next visited vertex, that is or edge visit BC. So B and C, all you can see B and C belong to the two different set. Then that's why we apply the union operation and merge A B C D. So then we combine all the A B and C D, and then we get A B C D. Okay, next we choose F G. You can see F and G. So from the previous uh, set, that is f and g belong to the two different set, so we can apply the union operation and then we merge this F and E. So we get E, F, G, and this is the another component, that is A, B, C, D, and this is the last, the B and D. We again choose B, D, that is U and V. So check the B and D belong to the same set. Yes, B and D belong to the same set. Okay, belong to the same set. Okay, B, D. So B and D also belongs to the same set. So you cannot apply the union operation, okay, in this case, because B and D belong to the same set. So after each design set and use a connected component applying all, so after traverse or visit all the vertices and all the edges, this is the final result, and you can see we find out the three different component of the given set, that is the universe U. So from the U, the given set or the given graph, that is G, we are finding out the or you can say the from the given graph we applying the connected component function and find out the uh, component. That means from the given graph we first find out the single elements using the mixed function, and after that we take one by one vertex and then check and then combine together, and then finally the connected component uh, gives us the result, that is from the given set there is three different components are there, and after that we can apply the same set function, and using the same set function randomly you can choose a B and C. If we pass the B and E from the same set function, it will return false because B and E does not belong to the same set. If we pass A and B into the same set function, or A and B use as a parameter, that is so it will return true because A and B belong to the same component. Okay, so after applying the connected component we apply the same component. Okay, and then check the two vertex belong to the same component or not. Okay, so next another example, this is a minimum spanning tree, and we are applying the disjoint set in the minimum spanning tree, that is find out that is a Kruskal's algorithm, and using the Kruskal's algorithm we are finding out the minimum spanning tree. So you can see this is the Kruskal's algorithm. This is the given graph. The vertex consists of the vertex set, and each set there are 1, 2, 3, 4, 5 vertex, and 1, 2, 3, 4, 5, 6, 7 edges are there. Initially A is the empty, and for each small v is belong to capital V, then we apply the mixed operation, and then that means using the mixed operation first we find out the want to create the vertex set. Okay, after that increasing the weight u and v do, that means we are choosing one by one increasing order. That means the Kruskal's in the first we short the edges in based on their weight value, and in the uh, increasing order, that means small to large, and then we choose one by one age and then check the set u and the v is to belong to the two different set. Then we apply the union operation, then that means we assign this age to the set A, and then we apply the union operation. So find set u and find set v. So first we take this one, okay, and check this vertex and this vertex belong to the to same set. No, they belong to the two different set. Then we apply the union operation and assign this age into the A. So we take this age. Next we choose the corresponding next highest vertex, that is this one. uh, okay, so next this one is the next height or the next minimum age. So again we check these two different vertex are belong to the same set. No, these two vertex does not belong to the same set. Then we apply the union operation and assign this age to the set A. You can see next we choose next minimum vertex, that is 3, and then again check this vertex and this vertex does not belong to the same set. Then we apply the union operation and assign this age to the set A. Next take the next minimum, that is 4, and if I choose this 4 and it then check this vertex and this vertex belong to the same set. No, this does not belong to the same set. But if I choose this age, then it will form a cycle, so you cannot choose this age. So we go for the next one, that is a 5, and then we take the 5 and we check this vertex and this vertex belong to the same set. No, these two vertex does not belong to the same set. Then we assign this edge to the set A, edge to the set A, and then we apply the union operation. That is, we take this vertex, and then we have already covered up all these vertex, because after that when we choose this edge, this also form a cycle. When choose this edge, this also form a cycle. So we complete the all the process, and then we'll find out the minimum spanning tree for applying the using the Kruskal's algorithm and applying the disjoint set operations like make set, find set, and union set. So you can see how we apply this disjoint set, three different operations like make set, find set, and union, and using these three different functions we find out the applications. That is, one is Kruskal's algorithm, and another is the social networking side, like the using the functions of connected component, where find out the relationship among those the set. Okay, the same that it is those people belong to the same networking site or not. They just we are find out their behavior. Okay, that's all. Thank you.